Hi, everybody, and welcome to this month's webinar on engaging students with cross-cutting concepts. My name is Judy Baccaro, and I am the 3-5 Science Virtual Teacher Specialist. My email is here on this slide. You are welcome to email me at this address, or you can email me through or message me through our learning community as well. So let's get started. So what are the cross-cutting concepts? Well, here we have a picture of a shell, and you'll notice inside it has this really neat pattern. And if I took another shell that was like that, I could have it and I'd find it again. So the first cross-cutting concept I'm going to share with you right now is patterns. And patterns are just structures or they could be events that are consistent and repeated. So patterns help guide classification, sorting, and other organizational structures like the periodic table of elements. We use patterns to prompt questions about factors that could influence a cause and effect relationship. And we also use patterns because they're useful for evidence to support our students' explanation or scientific argument. The second one here is we have a picture of a dam that has burst. And so this one would represent cause and effect. So events have causes, and sometimes these causes are simple, and sometimes they're multifaceted and complex. So a major activity of scientists is investigating and explaining these causal relationships and the process by which something takes place, or what we call the mechanism. So some mechanisms can be tested and used to predict and explain events in new contexts. And our third cross-cutting concept, okay, this is a building, and you'll notice that it has a certain structure. So this is structure and function. So what structure and function is just about the way an object is either in the natural world or the designed world, like the picture you see here. The way the object is shaped and how it's structured can determine many of the properties and the functions of the object or the organism. So if we're talking about in the natural world, those structures and shapes of a living organism, they can determine how the organism functions to meet its needs within its environment. Our fourth cross-cutting concept is stability and change. So over time, a system might stay the same, or maybe it could become different depending on a variety of factors. For example, this is a butterfly, but it changed. It didn't always look like this, but it has a predictable change. Okay. The concept of stability and change helps to focus on understanding how a system operates and causes for changes within a system. Our next cross-cutting concept is called scale, proportion, and quantity, or I like to refer to it as SPQ. So scale, proportion, and quantity has to do a lot with measurements, like the measurements of size and time that affect a system structure or performance. And sometimes even our ability to observe a system, such as something very large like the universe. That's very hard for us to observe the whole universe, just like it's very hard for us to observe something very small and microscopic without the aid of tools. So when we're thinking about phenomena and trying to understand or explain it, it's really critical to recognize what is relevant at different measures of size, time, and energy, and also to recognize how changes in the scale, proportion, or quantity affect a system's structure or the performance of that system. Our next cross-cutting concept is energy and matter. So many tracking energy or matter and that flow into, out of, or within a system helps one to understand the system's possibilities and the limitations. And finally, our last one is systems and system models. You may have heard me say that word systems in some of the other cross-cutting concepts. So what is a system? A system is just a set of connected things or parts forming a complex whole. So I have this picture of the solar system. So that has a part, the planets and other celestial objects make up our solar system. But it can also, so that's a macro system model there. But it can also be something that's maybe microscopic. So think about the cell. The cell could represent a system depending on how you're using it. So defining these boundaries of a system, as well as making a model of that system, provide us tools to help us understand and sometimes test these ideas that are applicable throughout science and in engineering. So those are our 7 cross-cutting concepts. So let's learn a little bit more about them. So I keep those in mind as we do, as we talk about what role do these cross-cutting concepts play in 3-dimensional science or 3D science. So one role that our cross-cutting concept plays is that it helps guide our students' engagement in the practices. So when you're introducing or showing a student a phenomena, sometimes it helps to show to have them look at the phenomena using one of the cross-cutting concepts. So for example, looking for patterns in the phenomena. What do you notice? What do you wonder? Okay, one thing, another example is it helps students, it gives you as the teacher some guidance, like what is the student thinking initially? So for example, if you asked your students to draw a model of how a sweater can keep you warm on a cold day, and it's an initial model, your students may not have an exact understanding of energy transfer, but they could use the cross-cutting concept of energy and matter to kind of get that idea across, even though they don't have the core ideas about energy transfer yet. So another thing about our cross-cutting concepts that is true for our disciplinary core ideas, and it's true for our science and engineering practices, is that they develop over time. There is a progression of understanding and complexity as a child moves from our K2 band to our 3-5 band, and then they get further complex understanding and use by students as they get into middle school and high school. So it's important that our students, have those experiences, because those skills build upon each other in our grade bands. Another thing about cross-cutting concepts is they're really applicable on all science and engineering domains. So they're not specific to life science, earth science, or physical science. They apply to all three of those domains and in engineering. So you can talk about patterns in all of those domains. You can talk about the other 6 cross-cutting concepts as well. Another thing that cross-cutting concepts, another important role is it can point out when a student is looking at their explanation of a phenomena, they can look at it and go, you know, I really need to put something about patterns in my explanation, and I'm really missing that. So it could help them evaluate their explanations and push them to go deeper within those explanations to really understand the science behind the phenomena. And finally, we want our students to use these cross-cutting concepts as tools to help them make sense of phenomena. So they can't be used in isolation. We want them to be used with those disciplinary core ideas and the science and engineering practices. We want them to be in combination with those and used as tools to help them understand the science behind the phenomena. So we're going to play a little cross-cutting concepts speed dating. So I hope you wrote down the 7 cross-cutting concepts. If not, rewind and go back and write them down real quick, because I'm going to show you some images of some cross-cutting concepts. And I want you to try to see which one you think this phenomena would highlight. Okay, here we go. All right, so here's our first image. It's on moon phases. What cross-cutting concept do you think you could use with this phenomena? And if you put patterns, yes, you could use patterns. So here's another one. Get ready. So I'm going to give you just a minute to read this explanation here about this phenomena. This is a scenario. All right. So what phenomena, what cross-cutting concept do you think we could use, that students could use as a tool to help them understand this scenario? So if you said cause and effect, yeah, you could use cause and effect for sure. Okay, here's our third one. All right, here we have a model of the water cycle. So which of our cross-cutting concepts do you think students could use as a tool to help them understand this model? Got your answer? Okay, let's see. You said systems and system models. Yes, they could use systems and system models to help them understand this model of the water cycle. Here's another one. Look at it carefully. What tool, which cross-cutting concept tool could we use with this phenomena of the trophic levels of the ecosystem? If you said energy and matter, yes, you could use energy and matter as a tool to examine this phenomena. Here's another one. Look at this photo of these 2 insects. And which tool would you want your students to use to look at these phenomena? If you said stability and change, yes, that's one tool they could use to look at this phenomena. Okay, here's our next one. This is the same, okay? But here we have the designed world, and this would be an example of the natural world. Which tool could we use to examine either one of these phenomena? If you said Structure and function? Yes, you most definitely could use structure and function. A student can use that. All right, so finally we have this one here. These are two separate ones. And if you said scale, proportion, and quantity, yes, a student could use that tool to with these phenomena to help them make sense of this. So one of the most powerful ways that cross-cutting concepts, so when you see C's, that means cross-cutting concepts, so just so you know, is to help students learn science, to help them learn science, is by providing multiple lenses through which they can make sense of phenomena. So this was taken from the book, Cross-Cutting Concepts, Strengthening Science and Engineering Learning. The editors for this book were Jeffrey Nordine and Oki Lee. And you can find this quote on page 11 of that book if you have it. So when we were doing that cross-cutting concept, you might have chosen a different tool for some of those phenomena, depending on how you wanted your students to engage with that phenomena, and that's okay. Sometimes it's good to use two different cross-cutting concepts tools for the phenomena. It helps deepen that understanding. So for example, if we go back to the moon phase, the picture of the moon phases, yes, that said patterns, but depending on how you're looking at it, if you want your students to explain how that pattern occurs, you could do one of two things. You could look at cause and effect. You could use that cross-cutting concept tool, or you could look at systems and system models if you wanted them to use that tool to help explain how the phases of the moon occurs. So you can use and combine the tools to as you see that your students need those tools to make sense of the phenomena. So in a minute, I'm going to show you a larger image of this picture here on the right. But for right now, I want you to get out a scrap piece of paper and I want you to make a T-chart. Okay, I want you to label one side what we notice and the other side what we wonder. You're going to look at this image of Maria's flowers, and this is taken in a park somewhere where students are and their teacher are observing. So I want you to put your student hat on and pretend you're a student and your teacher is taking you out and you're observing this photo, okay? So I want you to record what you observe in the notice side of your paper, and I want you to record any questions that you have on the wonder side. So as you're looking at that, think about the cross-cutting concepts and the tools you could use to look at this photo. Well, it's going to be a photo for you, but let's pretend like you're actually there. Okay, so I'm going to go on to our next slide, which has a bigger image. And I want you to pause this recording and write down your observations and your questions in the wonder column. Okay. All right, so here's some other responses from some teachers. So they put their notices here. What did they notice? They might have noticed some of the similar things that you have. You might have noticed things that they didn't, okay? And then their questions are here on the wonder side. So I just wanted to show you that as an example of how I do this with in a live session, and just kind of use this as to look at your own questions and your own observations and see how your thinking is the same or similar, or maybe it's different, and that's fine too, because we welcome all ideas in science. And here we go. So for this next part, I'm going to highlight some books that go with our either third, fourth, or fifth grade standards that you could use, and how to get incorporate that cross-cutting concepts in with your science standards. So for third grade, I chose the standard S3L1B, which is about animal adaptations or animal and plant adaptations. These books are paired, okay? So this book is about unbeatable beaks, and this book is just about beaks. So these books highlight the different types of beaks that birds have, and how the structure of those beaks allow the bird to meet its needs. So these books would be a great way to have your students use their structure and function lens. As you read this book to them, have them point out the structures and the functions of those structures that help the birds meet its needs. Okay. The other two books I have here are along the same lines. They're about ducks, okay, and how ducks are waterproof, okay? So this, again, an adaptation that allows the duck to not get wet, okay? So again, we're talking about structure and function. So as you're using these books or books like this, these are just suggestions. There's many more books that you could use, that or books that you already have your students put on the different lenses of our cross-cutting concepts. Okay, guys, I want you to use your lens of structure and function to help identify the structures and the functions that they serve the duck to help it meet its needs in its environment. Okay, so here's these are examples for third grade. I'm going to go on to fourth grade. And for fourth grade, I talked these books are paired. You don't have to use them together, but talking about the food chain, a lot of, maybe you do owl pellets with your students and have them dissect the owl pellets. These books go along with that, that topic very well. And again, think about what cross-cutting concepts for this standard. So for the ecosystem, food chains and food webs, you could talk about energy and matter. You could have them look at, as you read these books, look for example of the flow of energy in the ecosystem. So use that lens as I'm reading this book to help you identify the flow of energy. Okay, you could talk about what the birds eat, maybe the structure and function. They could use the lens there, the lens of structure and function, to determine what the owl eats if you do owl pellets. So there's a lot of different lenses that you could use here with this standard. Those cross-cutting concept lenses can be interchangeable and you can combine them. Okay, so the next one, these align, these two books, you could use these with your weather unit when you're talking about weather systems. So you could use your systems and system model lens to help them identify weather systems and to make predictions. You can also look at patterns, especially as they collect data and you're analyzing that data to make some weather predictions. You could look at cause and effect and use the cause and effect lens, depending on how, the phenomena you're using or how you want your students to engage with these books. So, it's kind of, you have some flexibility there, but some lenses are a little more obvious than others. I'll say that. And now I'm going to show you a couple other books. These are fifth grade, and these books you could use with your inherited traits versus learned behavior. standard, that's S5L2. So this book here, next time you see a spider web, talks about all about spiders, different kinds of spider webs that spiders make, or sometimes spiders don't make webs, but it talks about that. It goes through like the different types of spider webs, and it introduces a few spiders to them, but it also talks about, how a spider makes a web. And so you could talk about, well, do they inherit that ability to make a web, or is that something they learn? Another, this book on Nefertiti, the spider knot, if you haven't read this book or don't know about this book, it is based on a true story of a jumping spider named Nefertiti who was sent to space and lived in the International Space Station, and how this spider had to learn how to hunt with little gravity. And then they brought Nefertiti back to Earth to see how she would adapt back to Earth. So again, we're talking about learned and inherited traits here. So there's even some videos of Nefertiti that you could look up and watch. And it's really, really fascinating. But these are two really good books to pair together and talk about inherited traits versus learned behaviors. So again, we're looking at patterns here. So you could have your students use the pattern tool as you're reading this book to point out any patterns that they see, or maybe even some cause and effect. You could pick that up and combine that with that. So again, these are just really good suggestions on how to use just regular children's books that go along with your topic, and how to use the cross-cutting concept tools when you're engaging with these texts. So finally, what I want you to do is, in the discussion for our webinar, I'm going to link an article of a teacher and her children experiencing the same phenomena that you did before. And as you're reading their experience, I want you to reflect on your experience with that image. What did you notice? What did you wonder? What tools did you use when you were engaging with that phenomena? Did you use patterns and cause and effect, or maybe you used another tool? Okay, and how did these tools support you in your understanding of the phenomena? So just kind of compare and contrast. And in the comment section for this post, I would love to hear if you had any aha moments or something that really resonated with you, and why. So let's do some sharing with this and learn from each other about our experience with Maria's Flowers. So thank you for listening, and I look forward to your comments on the Maria's Flowers article. Have a nice night.